Okay, so hello everyone. Welcome to Licd Lab number 7. Today's objective is to design and implement a triangular and a sawtooth waveform generator in LT-Spice. So first I will show you one sample design, and based on these steps you can design with the values which are assigned to you. So here it is. Design a circuit which will generate a triangular wave of frequency 2 kilohertz and amplitude 7 volts peak to peak. We can assume the value of plus or minus Vsat as plus or minus 14. So accordingly, you can select the value of VCC and VEE. Okay, so the given data is F naught is equal to 2 kilohertz and V out peak to peak is equal to 7 volts. Now the output peak to peak value for a triangular wave is given by V out peak to peak is twice R2 upon R3 into Vsat. Okay, we'll look into the circuit of yeah, this is my triangular wave generator. So V out is producing a triangular wave and VO1 is producing a square wave. Okay, so these are the values of resistors R3, R2, R1, and here is my capacitor C1. So let us go back to the design. So over here, V out peak to peak desired is 6 and Vsat we have assumed it to be 7. So we get R3 in terms of R2. You assume the value of R2 as 10K standard. So R3 will be around 40K and the standard value will be 39. Now in LT-Spice, you can take the value directly as 40 kilo ohm. Now for the frequency of oscillations for the triangular wave generator, the formula is given by F naught is equal to R3 upon 4 times R1 into C1 into R2. So F naught is given as 2 kilohertz and the value of R2 and R3 is known to us. So we assume the value of, we get a factor of R1 and R1 C1 is equal to 1 upon 2 into 10 raised to 3. So over here it is easy to assume the value of C1 as 0.01 microfarad. And if we calculate in a calculator, you will get the value of R1 as 50 kilo ohm, which you can put directly in the LT-Spice, or the standard value if you can take it as 51 kilo ohms for the quarter watts resistor. Okay, so that's the standard value of resistor which we can take. So once you have designed the circuitry, you get all the values of resistors and capacitors. So simulate this circuit in LT-Spice and you will obtain these waveforms. So these are my triangular wave. So basically your VO1 is my square wave and V out is my triangular wave. So over here, like this, you should get the waveforms closer to this. Basically, for a low speed op amp, you will get a slight slope over here. The green line won't be vertical over here when it is changing from plus Vsat to minus Vsat or the other way around. So you will get a slight slope for a low speed op amp. For a high speed op amp, you will get similar waveforms. So my V out is my triangular wave, which peak to peak value should be around 7. So you measure it in LT-Spice using the cursor. And similarly, you note down the peak to peak amplitude of a square waveform, which is VO1 over here. And you also measure the time period, which will inverse of it will give it the frequency. So write down the observation table. This is the way you will write down the observation table for the slow speed op amp and for the fast op amp. VO1 peak to peak, V out peak to peak, and frequency. So simulated and theoretical values you can mention it over here. Mention it over here. Now for the second half, we need to do some slight modifications in the triangular and square wave generator to convert into sawtooth waveform and rectangular wave generator. So what we need to do is, in this op-amp earlier, the non-inverting terminal was connected to the ground. So over here, you can connect it with a resistor RA and resistor RB, split it into two parts. Here you can connect VCC and VE supply. And for the first case, you consider RA to be greater than RB. And for the second case, you can consider the other way around. That is, RB will be greater than RA. So you can, if you change this RA greater than RB, you will get a sawtooth waveform with a rise time and fall time as follows. Okay, so these are the waveforms you will get for if you change the value of RA, will be less than RB. So over here the T on time will less than T off time, but the rise time will be greater than the fall time over here because the output of the integrator will be negative. So that's why it's a reverse actually. So over here, if you check carefully, let me just show you. So this is the on time and this is the off time. So ideally speaking, the on time should be same as your the rise time, But over here, what is going really happening is, let me go back to the circuit. So over here, output is feeded, this output VO1 is feeded to this integrator circuit, and integrator circuit, the output is negative because this is applied to the VO1 is acting as a input to the non-inverting terminal, right? So output will be negative. Hence, the rise time and fall time are interchanged over here. So here we have T on less than T off. So for the rise time will be here, the rise time is greater than the fall time, as you can see over here. Okay, and this is my sorted waveform, and this is my rectangular waveform. So this waveform you will get once you simulate this circuit, and here the amplitudes will be plus or minus 14 for the rectangular wave and plus or minus 3.5 for the sawtooth waveform. Okay, if we reduce the rise time less than the fall time, you will get this kind of a waveform. So other type of sawtooth waveform you will get. So here also the amplitudes are similar, plus or minus 14, and the triangular wave, the sawtooth wave amplitude is 3 plus or minus 3.5. Okay, so you have to perform this task. Just wait a sec. Okay, so to systematically put it, for the task number one for this lab is design a triangular and a square wave generator for frequency of 1 kilohertz and output peak to peak of 6 volts for even roll numbers. So if your roll number is ending with a even, if it is an even roll number, you have to do it for f not equal to 1 kilohertz and peak to peak triangular wave amplitude should be 6 volts. And for the odd roll numbers, you need to consider the value of f naught as 1.5 kilohertz and v out peak to peak as 5 volts. Okay, so very specific. Again, I repeat, for odd roll number, for even roll numbers, f naught will be 1 kilohertz and v out peak to peak will be 6 volts. For odd roll numbers, f naught will be 1.5 kilohertz and v out peak to peak will be 5 volts. Okay, for even it will be 1 kilohertz and for odd it will be 1.5 kilohertz. So we need to simulate. We have already seen the design steps, all the design steps included. You can write it in a piece of paper and upload it in the Google document, assigned Google document. Now the task number two is simulate the circuit. In task number one, in LT-Spice using high speed op amp and low speed op amp. So low speed op amp is OP07. High speed op amp you can select it as LTC6244. Now record the readings, record your readings obtained in the task number two in the observation table. That's what I have already shown you also. So this is the table you can do that, recording of the readings. Now next is modify the circuit in task 1 to obtain the sawtooth and the rectangular wave generator using only high speed op amp. So here it is. So this is the modification required, RARB registers externally required to obtain the sawtooth and the rectangular waveforms. And again, the task number 5 is record the readings obtained in task number 4 in the observation table. Okay, so this is the observation table for that. So this is the observation table for the sawtooth and rectangular waveforms. I hope that this is clear. Okay. Now let us go to various plots. So there will be total 4 plots. First will be the output triangular and square waveform using low speed op amp. Second will be output triangular and sawtooth waveform using high speed op amp. The third one will be output sawtooth and rectangular waveforms using high speed op amp. You have to include both the circuit diagram and the output waveforms. Okay. So over here, these are the plots, but you have to include the circuit diagram also. So for output and rectangular, for sawtooth and rectangular waveforms using high speed op amp, one case for rise time greater than fall time, and second case for the rise time less than fall time. Okay, so this is your 5 tasks for today for this LICD lab number 7, and please complete on time and upload all the documents in all the print screens in the Google document assigned. Okay, so that's it for this lab, and implement and design the triangular and sawtooth waveform generator. Okay, thank you.